All right, this is Chapter 6, Lesson 6, the Distributive Property, page 485. This is going to be part 1 to this lesson because I'm going to break this lesson up into 2 separate lessons. This is on distributive property. The next one will be on factoring. So just like I did on one of the other sections that we had previously, I'm going to section this out into 2 sections. All right, so this is what your pages should look like. The first thing that we're going to look at is the real world link. It says 3 friends went to a baseball game. Each ticket cost $20 and all 3 friends bought a baseball hat for $15 each. What does the expression 30 times 20 plus 15 represent? You're going to say what the 3 represents, the 20 represents, and the 15 represents. And then you're going to evaluate the expression. So go ahead and do 1 through 5, and when you come back, we'll go over the answers. Alright, so for number 1, the number 3 represents the number of friends that are buying things. The 20 represents the cost of each ticket. The 15 represents the cost of each hat. And then for number 2, 20 plus 15 is 35, and then we take 35 times 3, which is 105. So it's going to be $105. Number 3 says, what does the expression 3 times 20 plus 3 times 15 represent? So 3 times 20 represents the cost of the tickets, and 3 times 15 represents the cost of the hats. And then evaluate the expression 3 times 20 plus 3 times 15. We would do 3 times 20, which is 60. Then we do 3 times 15, because remember we do, please excuse my dear Aunt Sally, so we're doing our multiplication from left to right. That would be 45, and then we take those 2 numbers and we add them together. And what we find out is that they are the same. It would be $105 either way you figured it out. So if you wanted to say, okay, it's $35 each times 3 people, that's fine. Or if you want to say, okay, it's $60 for the tickets, it's $45 for the hats, so it's $105 for everybody, that's fine too. Alright, so distributive property says to multiply a sum by a number, multiply each addend by the number outside the parentheses. So what we're talking about here is doing the rainbow. They do it underneath. I like to do it over top. So it would be like saying, okay, we're going to do 2 times 7, which is represented here, plus 2 times 4, which is represented right here. So 2 times 7 would be 14, plus 2 times 4 would be 8. And so 14 plus 8, 22. Which if you checked it, if you did 7 plus 4 inside the parentheses and got 11 and multiplied that times 2, you would in fact get 22. So it's just showing you that it's going to work either way. So distributive property just means that everything that's inside parentheses has to be multiplied by what's outside. So there's no sign between the number and the parentheses. That means multiplication. And so I'm going to multiply everything inside the parentheses by that number that's outside. When I do that, don't forget to keep my addition sign in there. So the expressions 30 times 20 plus 15 in parentheses and 3 times 20 plus 3 times 15 show how distributive property combines addition and multiplication and how it works. So number 1, it says find, sorry about that, 9, 4 1/3. So the way that they're saying to do this is by using distributive property. Let's separate the 4 1/3, and 4 plus 1/3 is the same as 4 1/3. So they're saying let's rewrite it as 4 plus 1/3. And so we can do 9 times the 4 plus we can do 9 times the 1/3. Oops. And when we do that, it simplifies having to do the 1/3 part, because you can just quickly cross simplify and divide by 3, which makes this a 3 and this a 1. And now you can deal with 36 plus 3, which is a lot easier than doing 9 times 4 1/3. And so the answer would be 39. So let me show another example like that, because I think this is a really good way of looking at distributive property. So let's say that we're doing 5 times 3.5. Well, that's not a very good example. Hold on. 3 1/5, we'll say. Because of his mental math, we want to be able to do it fast, and that was going to make a fast one. All right, so 5 times 3 1/5. They're saying let's do 5 times 3 plus 5 times 1/5. So we're just taking this and separating it out as 3 plus 1/5, and we're multiplying everything by 5. So 5 times 3, and then 5 times 1/5. And so the 5's both cross simplify to make 1 each. So now we have 5 times 3 is 15, plus 1 times 1 is 1. And so we end up having 16 as our answer. All right, which wouldn't be obvious doing 5 times 3 1/5. We'd have to do, you know, MAD, where we make it an improper fraction, and then we would be able to cross simplify then, and then we would get our answer. So this is just a mental math method of doing this, where we don't have to use MAD. Oh, good. So here's some examples for you to try out for A, B, and C. You'll notice C is dealing with a decimal, but you can separate a decimal just as easily. So let me give you an example of a decimal. If we had 4.5, that's the same as 4 plus 0.5. And if you'd like to change that to a fraction to make it easier, you could always say 4 plus 1/2. So if you'd like to change that 0.6 to a fraction to maybe make it easier for cross-simplifying, you can try that out. It's completely up to you. All right. Either way, I think it'll be fine. It's not a very hard thing to do, 2 times 0.6. All right. So go ahead and solve A, B, and C, and when you come back, we'll go over them. Pause now. All right, here are the answers. If you'd like to pause the video to be able to take a check and see why maybe you've gotten something wrong, and you can look through my work, maybe that'll help you figure it out. So example number 2 says use distributive property to rewrite 2 times x plus 3. So I like that they showed once again our visual, our models that we've already practiced in class and at home in the last video. So if we have 2 times x plus 3, and we're using a bar for our x and a dot for our 1's, then I would set this up as saying, okay, here's 1x and then 3 1's, and 1x and 3 1's, and that gives me my 2. Okay? And so if I'm figuring out how much I have all together, then I would say, okay, I've got 2 x's plus I have 6 1's. And so there's my answer, which is the same as saying 2 times x plus 2 times 3. And you can't forget to do the 2 times 3. That's where people make a lot of mistakes. A lot of times people are going to say, oh, the answer is 2x plus 3. No, if you look at this, you've got 6 dots here. That's a lot more than 3. So please make sure that you are doing your rainbow all the way. So you're going to do 2 times x, which is just 2x because we don't know what x is. Then plus 2 times 3, which is 6. So we end up with 2x plus 6. All right, now you go ahead and do some of these examples yourself. If you'd like to draw the pictures, draw the pictures. If you'd like to do the pretty rainbow, do the pretty rainbow. But please don't forget to multiply everything inside the parentheses by what's outside the parentheses. All right, so you're doing D, E, and F, and I'll come back and show you my answers. Pause the video now. All right, I know there's a lot going on this example here, but I wanted to do both examples. So the first thing I did was show the using the bars and dots, and then I also did using the distributive property where we have our rainbow. Okay, so look at my final answers. They're all circled. For E, if you made it 5x plus 45, it's the same as 45 plus 5x. So it doesn't matter which one you used. So check your answers for D, E, and F. And if you need to pause to look over my work, you can do that as well. Example number 3, Fran is making a pair of earrings and a bracelet for 4 friends. Each pair of earrings uses 4.5 centimeters of wire, and each bracelet uses 13 centimeters. Write 2 equivalent expressions, and then find out how much total wire is needed. So the way that she set it up, she said, okay, well, I need 4 I'm making 4 of each. So I need 4 times 4.5 and I need 4 times 13. So that's one way of doing it. 4 times 4.5 is 18. 4 times 13 is 52. Add them together and I get 70. Or I could say, okay, I need 4 of 4.5 plus 13. So 4.5 and 13 will make up both my bracelet and my earrings, and I need 4 of them. So I'd figure out 17.5, and then I would multiply that times 4, and I would end up with 70. So either way, I'm going to end up with 70 centimeters of wire that's needed. So G, you're going to do this on your own. Each day, Martin lifts weights for 10 minutes and runs on the treadmill for 25 minutes. Write 2 equivalent expressions and then find the total minutes that Martin exercises in 7 days. So go ahead and solve this, and when you come back, I'll have the answers. Please pause the video now. Alright, here are the 2 separate ways of writing it. Doesn't matter which order you put it in. One of them is where I do 7 times and I combine the 10 minutes and 25 minutes together in parentheses. Or I could figure out how much I have of each day and then add them together. So I could do 7 times the 10 minutes of lifting weights plus 7 times the 25 minutes on the treadmill and then add those 2 amounts together. And either way, the total answer is going to be 245 minutes spent in 7 days exercising. Alright, that ends the first half of our distributive property. You're going to see part 2 for factoring, and we'll work that out later. Thanks. See you in school.